Hey everyone. Welcome to the final presentation by Anuj. Anuj has been working on verifying Schnorr signatures from Mina on EVM. So thank you, Anuj, for joining. Over to you.
Hi. Yeah. Hi, everyone. Nice to meet you. So, the project's title that we'll be discussing today is Mina Schnorr Signatures Verification on Ethereum. So, the way it works is we have a Mina signer package that helps us verify signatures. I mean, to be specific, fields and messages. So, what I've tried doing for this project is to make that verification process compatible with EVMs as well. So, the before I get into it, the first point I would like to let everyone know that computations like these are very expensive. So I have developed the main verification on EVM, but I've deployed everything on Arbitrum at the moment. And to get it on Ethereum, I've also deployed a messaging solution by Layer Zero. So what it does is it lets you read information from Arbitrum and delivers it to Ethereum. So that way you can have data availability on Ethereum as well as Arbitrum. So because of that, we have reduced the gas costs because, like I said, the computations are expensive. So doing everything on Ethereum for just for one single signature gets really expensive. And the more data you have, there is no cap on the gas that is being used. So uh, can I share my screen now?
Mhm.
So I would like to give you guys a main intro to how everything works, like how would a person go about verifying their signatures. So let's see.
Anuj, could you also speak about what makes it harder right now to translate or verify a signature which is on a different curve onto a curve, which Ethereum supports?
Yeah. So the thing is, when I was working out this specific project, so we have Palace Curve. Let me stop sharing first. Yeah. So the main curve that Mina uses for signatures, I mean, you have a signature object that is over the Palace curve. So whatever data you have, so the signature is dependent on the curve and it exists on top of the curve. So the way it works is the verification process is actually pretty lengthy. So it would be hard for me to explain it over the call. But what I have done is let me show you guys 1 second. So we have these various parts of the verification scheme that we have. So as you see, like this is the main Mina signature of what do you say package.
Mhm.
So if I go over here, like this is the main code for the verification as well. You see this verify field. So I so whatever related files that we have here under Mina signature, I had to also port them to EVM to make sure that every mathematics that happens, it matches the verify fields or verify message 1:1. So everything that you see here, all of these steps, first you get the public key, then you generate the E, then we have different operations over the Palace curve, this like scale, one and sub, and producing this value, then confirming it against this value. And if it comes out to be true, that then you say that the signature is valid over Palace curve. So
Mhm.
like this is specific for what do you say fields. And for messages, we have a verify legacy method under Mina signage signature. So I also had to create, so essentially I had to create two different what do you say logic execution, one for verify messages and one for verify fields. So we have two final smart contracts. Everything that's behind the smart contracts is based on this Mina signer package. And everything that you see here, every function that you see here within like say verify legacy or verify for fields, all of this is available on the smart contract as executable functions per se. So if I just give you a small rundown of the main smart contract, this is the main contract that verifies signatures over messages. So it's actually inherents from multiple files, and all of the functions that you see within those JavaScript files, we have a 1:1 like replicas over Solidity. So every function that you see that's being used by those verification methods under Mina Signer package. So all of this is available on the smart contract. So the main issues that I mostly faced were regarding the size of the data, and the other one was making sure if how the messages are packed before being verified, before being signed by Mina Signer. I had to also like make sure it was matching that. So it took me a while to like make sure everything works and matches how the execution actually happens inside the Mina Signer package, like for verify message and for verify fields. Yeah.
Awesome. Very briefly, can you talk about what is the difference between the two methods? If
Yeah. So the thing is, the core of both methods is same. I mean, how we do the operations over Palace curve, but the difference that comes is how these messages or fields are packed before going over to the main verify signature thing.
Mhm.
So if you go over to Mina Signer, let me show you guys. If you go over here, verify message, verify string signature. So the way it works is we have two different verification schemes. One is verify legacy and the other one is verify. So the main difference between both of these is how the main data is packed. So in verify fields we have a more latest, or it was Poseidon Kimchi proofs to pack those messages, I believe. And for legacy we had some legacy parameters for hashing the main data that we have.
Mhm.
So the main difference, the way it works is we have different hashing schemes, but eventually the final data that is being like how you verify the signatures, that part is same, but the way
Mhm.
the data is initially packed, that is different for each of these methods. So verify message uses the legacy way of hashing, and your verify fields uses the more latest kimchi, what do you say, hashing. So let me see if I can find that. So if you see here, we have here hash legacy. This was for your legacy hashing, and the other one is verify. This is the more latest
Mhm.
your kimchi Poseidon. So that's the main difference that we have between the verify fields and your verify message. The way the message is hashed before being verified.
Yeah. Thank you for the explanation.
Yeah. Also, just one more thing to add. The hashing is also dependent on how we define the parameters for the Palace curve, and then Poseidon. I mean, it had different constants for Poseidon. It means so we have these constants, and these are different for your legacy and your
Mhm.
kimchi proofs. Yeah.
Right.
So we have different matrices and round constants. These are all dependent on the main mathematics of how these curves behave, I believe. And so this is how like these things, I mean, are different at a core level.
Mhm.
So that's why I have individual contracts for both of these. One is for your fields verification, and the other one is for the message verification. So let me give you a quick rundown of how it works. So I have created like a main repository for this project. We have your deployments information over here, like where everything is deployed, all of the smart contract addresses. And we also have a README to like let people know how to get started, over like if they want to test it out. So our main logic exists on core inside the core directory. Let me go there. This is the main code, and the other directory is layer 0 compatible, and this is for your hybrid model that brings the Arbitrum data over to Ethereum. So let me like give you a quick rundown of how everything works. So start with verifying some fields. So if I go over here, we have your verify fields. So these are the main fields that we'll be verifying today, and the signature would be like gathered from Mina Signer again. We are using Mina Signer again for signing over these messages, and we will be verifying it over Ethereum on EVM chains. So let's see. Let me change the data for the sake of this example. Let me add some values, remove some values. So this is our final fields object that will be first signing using Mina signer, and then we'll verify it through our EVM contract. So I've made the changes. I'm running it over Arbitrum. So what it does, it picks up the latest what do you say unique ID for this, and for this, since the competitions were very big, I had to divide the main competition over multiple steps. So our main step would be, from a user perspective, the major input that would come would only be limited to the step 0, which asks the user about the public key that's signing, and the signature object rs values, and the data that was signed. And this is another flag that I mean, it checks the network. I mean, we have a field regarding networks on Mina signer, so it lets people sign messages on testnet or mainnet. So if you look here, the smart contract verdict also came out to be true, and the Mina signer verdict was also true. So I sent the same data that I signed using the client. We have the same data, and we can see, like, our smart contract also verifies that this was true. Let me go over to the verify message now. So let's say you're a protocol and you want to make sure the Ethereum addresses of a user and the Mina addresses are linked together. So in that sense, you can say sign this message to verify you have access to to this wallet, and also you let's say your wallet address on Mina is, let's say it starts something like this. So this is your message that you're getting from the user. How it usually is, you get a signature using Oro wallet or something. So in the same sense, you can have a message. Let's say this is the final message. So let's go with this. So what it does is it checks certain values, then it starts with the assignment, the assignment transaction confirm, the step 1, step 2, it goes over to each step, it verifies them. So let's see what's the final verdict. It takes about 30 seconds to verify everything on Arbitrum. So as you can see, the Mina signer verdict was true. Like, this message, the message was actually signed by a specific public key, and also our smart contract verdict came out to be true, which means the state was verified on EVM chains that, yeah, this signature belongs to this public key, and the original message was what we wrote here, this message. So this is essentially the main functions for these smart contracts. Like, you input the fields, you input the message, and then you can confirm if it's a valid signature or not. So if I just give you a quick brief, like, this is the main object that's being stored here on chain. This is for verify state, verify fields. Six is the latest one.
Yeah, could you
So
speak a little bit about these objects on chain? And I guess I also had a question. Your verifier is stateless, right? And did I understand correctly that in order to verify, you need to send multiple transactions out
yeah,
to?
yeah, 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 yeah. So I'll go with that if you want. Yeah. So
Sure.
let me just give you a quick brief. Like, this was our initial fields that we wanted to be verified. So if we go over here, these fields actually match with what we have on chain. So if you look here, like, these are the exact same fields that we just generated and
Mhm.
verified. Let me give you a quick brief of the object that's on chain. Okay, so since the computations are expensive, so like I said, I had to divide these steps over multiple transactions. So you see all of these values, like in it, this is the main fields object. that's generated when a user assigns certain fields. So these stay on chain, and you can always come back and verify individually.
Hmm.
These are after the thing that you see after here, your SG point, your EPK, and R. These are the intermediate points that we had over here. Let me show you guys. So if we go over to verify, you see these values, your E and R, and your, so these values, these intermediate values, we have that over here in your palace types. The result of multiplication, your EP, your multiple R values, these intermediate values that you see on Mina signer, it's the same values that we have on chain, so that people can verify like what were the intermediate values for calling these functions. It's the same for what do you say, messages and fields. So like we have the intermediate values for fields, you have that for messages as well. So these are the intermediate values, and all of the other values, these come usually from how we have said sent the first transaction. So if I go over to, like, just to give you an example of the fields, where's this? So this is the main function that requires user input. After that, everything is mostly based on the verification ID that you have already that that you get after calling the first zero step. So it requires a public key, x and y value. It requires a signature value and your fields, whatever you want to verify. So we have a at step of what do you say, variable under the verify field state. You have one init that says like we have started with the verification process. The mainnet variable just lets the person know if we are signing using Mina signer on
Hmm.
testnet or mainnet. So verify there's also this like small detail that fields values, they don't need to have, I mean, we can work with testnet and mainnet both, but the prefix says the same for Mina your
Hmm.
fields. But in the case of what do you call that message, the main, so one second, let me, if you look over here, uh, we have your network flag that says if it's on mainnet or testnet, and the prefix is decided since it's important to make sure that the signature that was signed on testnet cannot be used on mainnet. And since a lot of protocols require that you verify on mainnet instead of testnet, so we have this flag to make sure like the overlap doesn't happen, and one signature that was like signed by someone on testnet cannot be used on mainnet. And your verify fields is, it doesn't matter what test, if you're using mainnet or testnet, the prefix remains the same, that's coda signature. And this is the all of this is coming from Mina signer again. Like, I have not introduced any new information. All of this is how Mina signer behaves for verify fields and for verify message
Cool. Awesome. Thank you. And since you're storing this data
on
like
chain.
the
Yeah,
yeah, verification states on chain,
yeah,
there's also no way for someone else to come in and
yeah, yeah.
like uh,
Yeah, that was the main
yeah.
intention for introducing these intermediate states.
Hmm.
So anyone can verify individual steps if they want to.
Right. But no one can hijack my verification
No, no,
step.
no, 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 no.
All right. Thank
Since,
you.
but you can, what you can do in theory is you can delete your already existing.
Mhm.
So let's say if I verified like this specific, and let me show you guys. So my ID over for verify message was 5. That was that I just recently what do you say, sent on chain. So I have this flag to delete the information if I wish to,
Okay.
which is clean up VM lifecycle, and it
Hmm.
requires that I was the one who created this specific lifecycle.
Hmm.
So that way, if I'm actually the owner of this so if I call it right now like cleanup VM life cycle using the account that I used to send this on chain, I can clear it as well.
Awesome. Yeah. You've thought of everything.
Yeah, yeah, I've tried to. Yeah. So these are the main functions. Like we have your verify fields and your verify message. So this was the main what do you say, scope of work under the what do you say, this specific navigators program. And but I've introduced an option so as to make all of this much cheaper. So to give you an estimate, I've also made a graph for this to give you an estimate of the computation costs. So let's say you are trying to verify one field of one character over Ethereum. So that was costing me about $250. This is based on the amount of gas being used and the price of the gas that we had at that specific point of time. It was
Mhm.
somewhere around 11.5 GUI. So because of that, verification of one fields or one character was costing me about $250 at the very start. And if we go over, like, increase the number of fields that I want to verify or the characters, we can see these are like going exponentially high, like as you increase the amount of data available. So on Ethereum, like one single process was costing me about $1,100 and $370 for fields and character respectively. And for a final test, I chose like 100 fields and 100 characters, and you can see it's really high compared to what we have on Arbitrum. So that's why I thought about pivoting to a hybrid model that lets me run the main what do you say, verification model on Arbitrum, and I can access the state on Arbitrum over Ethereum using layer 0.
Mhm.
So essentially, like if you say if you have a really big array of fields you want to verify, or let's say the message is big, pretty big. So on Arbitrum, the costs are like totally minimal compared to what we have on Ethereum. Just to give you an
Wow.
example.
And is the limitation only by the amount of fees you need to pay, or is there also a gas limitation you faced on verifying on Ethereum?
I mean, so the thing is, the the main point that I had was like you said, the gas limitation. So
Hmm.
that's why I tried to modularize the amount of steps that I had instead of squeezing everything in. Let's say if I have 6 steps, I can definitely squeeze them into maybe 4 at tops.
Hmm.
But I thought about making sure that every after every step you only work on just one variable that's part of the whole verification process.
Hmm.
So the number of steps being 6, it's mostly based on me trying to keep every individual variable being generated over one step. So I
Hmm.
can definitely squeeze like 2 steps into one, but I cannot go about squeezing like 3 or 4 steps because of the gas limit, like you said.
Okay. So in its current form, there's a very good chance if someone wanted to pay a very high fee, they could still deploy it and verify it on Ethereum L1.
Yeah, if they can
Yeah.
afford these
Yeah.
costs for one verification, they can.
Cool. Cool. Thank you.
Yeah. So just to, like I said, just to mitigate all of this, I pivoted to layer 0. So it allows me to have the same. Let me go over to this. Mm, Hybrid module. Yeah. So this like you said, this is like the deployment version first, which is like the hard coded contract without the cheap data availability hybrid model. So you can deploy everything on Ethereum. I mean, just Ethereum alone, but the fee would be really high.
Hmm.
But the hybrid model, like what I've also I've completed all of that. It's the hybrid model. So what it does is it computes on Arbitrum and all of the important states without the intermediary state that would be available on Ethereum. So instead of having every middle field you have, that I had to make what do you say, I had to make some changes to the amount of data I can transfer over to Ethereum. So what I've done is I've only included the public key, the signature, and the message that was that was signed, and brought it over to Ethereum. So it's missing certain values on Ethereum, but the main important values are available on Ethereum. Your signature, your public key, and what do you call that? And your, if it's true, if it was verified or not. let me show you. Like I also have that if you want to see. So these field bytes. So I've already documented everything for anyone looking to like replicate this. So we have an order of execution under the README. So the core files verification layer on L2 Arbitrum at the moment. You can verify fields, you can verify message for fields, alter the fields according to you and verify them or alter the message according to you. Then you can get the verification state or the verify message state like we have here. The all of the intermediaries value as well. So let's say, let me try message as well. So the latest message the ID for the latest message was 5. So it will ask you for the ID, and these are all the your intermediaries value. And this was the original message that we had. If you can we can also confirm this was the original value by going over to the verify message thing. And as you can see, this was the message. Sign this message to verify you have access to this wallet. Also, your wallet address on Mina is this. So this is how you can get the state. Now, for the layer 0 to work, we have these field bytes and message bytes. So the way it works is what do you say? Encoded every state value that was generated using the fields and the messages into a bytes memory format. So this is important when we come over to the layer 0 integration that I've done. So if I get the field bytes, what was the latest thing that we did? It's 6. So this 6 is this is the state that's for ID number 6 in bytes format. So this is important when we come over to the layer 0 integration. I'll show you in a bit. Let me also get you the message bytes for fields 5. Your ID5, sorry. So these are the byte object that's being generated for the state for ID number 6 and ID number 5. Let me go over to the layer 0. So I've created a contract that layer 0 integration requires certain inputs from the user apart from these. So I've made a simple like step-by-step guide somebody can follow. So it requires input data from Solidity in bytes format. So you see these values, we can copy this value. We can paste this value and its unique ID. What the unique ID was 5. So it gives me certain values. These will be important in the coming steps. So you have a call data size and you have a gas limit size, your gas limit. So these comes handy when we're trying to read the state on Ethereum. So how a person would go about is you follow all the steps on Arbitrum, and after that you move on to this stage to bring that Arbitrum data over to Ethereum. So we'll be using the read manual. So there are two ways a person can go about reading the state on Ethereum. One is automatic way, that's simply named read, and the other one is read manual. So the difference between these specific methods is mentioned in this README file. So we have the automatic flow and the manual flow. I'll just give you a quick rundown after I've shown you how it works. So if you go over here, read manual, let's see. So this is happening on Ethereum. The verification type, F is for fields, M is for message. Let's try verifying reading this thing. Verify type 1. So this is message. So this is message. Your ID, what was the ID? 5. Your call data size. Now this comes in from this function that I showed you just now. You copy it, paste it, your gas limit, copy it, you paste it. So it gives you a rough estimate of how much this is going to cost you. So for bringing our message from Arbitrum to Ethereum, this specific message that we signed, what was it again? This message, it's going to cost us about this much Ethereum. and based on the current rates, this is somewhere about 20 to $25. So compared to the initial costs that we had, if I go over here again, for 100 characters, like it was about $400, but now because of this layer zero integration, this comes out to be somewhere around what do you say, $20 instead of $470. So based on the amount of savings that we're doing, it's more than 80 to 90%, I would say, which is really good if you want to have cheaper costs, since that's one of the barriers that people face when trying to verify something as complex as Mina Schnorr signatures on EVM chains. So let's say I want to continue. So what it does is it creates a transaction. Now this transaction hash will come handy as I can view what's happening using layer zero. Like layer zero has a separate block explorer for this. Let me change my sharing screen. Can you see my screen now?
Uh, yeah, the Explorer is up.
Yeah. It takes a bit time, like 1 or 2 minutes to index, and then yeah. So we can see it's in flight. It's going to take like about 3 to 4 minutes to bring over the data from Arbitrum to Ethereum. So let me show you some already existing thing that happens. So this is the exact contract that we have right now on Ethereum. I've already done a few deliveries. So this was for, this is our current message that's in flight. It's going to take a bit. So this is the response that comes in from your layer zero, and
Mhm.
this gets executed on your Ethereum contract. We'll have to wait for a bit before we can show that. Yeah. So while we wait for the, do you have any questions, Harish, by any chance?
Uh, I think I have maybe just one passing one. Is there like uh, any limitation on how many number of blocks on Arbitrum have been passed before layer zero can index
Yeah,
and bring
so
through?
I've made a block confirmation limit. So
Okay.
so I've tried to kept it short to only 3 blocks before you can
Okay.
bring over the state. So at the moment, the number of verifications that you need on Arbitrum to bring over the data to Ethereum using layer zero is only three.
Okay. All right. Cool. Thank you.
You can see my screen, right? Let me
Yep.
just.
Yep.
I have this bridge contract. So I've made some. Yeah. So these are the configuration files for this, and you
Hmm.
can see chain configurations, which gets updated to block confirmation. So I've kept it at 3 for the time being. So it makes sure that the data that's coming to Ethereum, it's at least the what do you say? It's confirmed by at least 3 blocks.
Gotcha. And I'm guessing this is more something which you need to define at a smart contract level rather than a
Yeah,
single
yeah,
VM execution level. All right. Thanks.
yeah, yeah, yeah. I mean, it's more about configuration for layer zero contracts.
Hmm.
So yeah, so everything over here is configurable by the deployer contract.
Hmm.
So anytime, like in future, if the community requires that the block confirmation time to be reduced from 3 to 1, in fact, that can be arranged. Yeah.
Cool.
So yeah, one point. So I'll just show you. So the data that actually comes on, what do you say, on Ethereum using this format, it's actually a bit. I've named that structure compressed because it only picks up the important values from the overall structure that we have on Arbitrum at the moment. So we have one field state compressed and message state compressed. This is the unique ID, say for whatever you're trying to read. So Since we were reading ID number 5, so the ID would be 5 over here. It checks if it's on the signature was on mainnet or your testnet. It brings over if the final value was valid, like the signature got verified or not. The public key that's associated with the signature, the actual signature, the message hash that's different for your message and fields, how explained at the very start. Like you
Hmm.
have legacy method of hashing the message for your messages, and you have your kimchi hashing for your fields. So this message hash would it's dependent, like this is separate on a more Poseidon level. Then you have the prefix. The prefix is there are two values for the prefix. One is your coda signature, and the other. Let me show you. Mm, mm, mm. Yeah, yeah. So the prefix can either be Mina signature mainnet,
Hmm.
or the for testnet it's coda signature and these asterisks. Yeah. So we have this is the prefix and this is the testnet prefix. Let me go over here again. So you have the prefix and this is the actual data that's being transferred. So like for our initial example, let's see. This is the fields array that was generated. So it's going to, like, we are bringing that as well over to Ethereum. This will be storing those values, and for messages, this message would be stored in this. So
Gotcha.
I made a more compressed structure to bring data from Arbitrum to Ethereum. So these are the main, like I said, the main, what do you say, most important points. So
Mhm.
I've kept the intermediary states on Arbitrum. I have not brought them over to make sure this transfer of information could be as cheap as possible.
Mhm.
Let me see if how's the, yeah. So you see it's delivered, and I can access this state on Ethereum now. So let
Gotcha.
me confirm. But yeah, so we went over to this. Yeah. So our message verification ID number 5. Let me see if it's available on Ethereum or not. So this is the Ethereum contract that I have. Your message, your ID number 5. Yeah. So this is now available on Ethereum. Your ID number 5, it was signed on mainnet. It's valid. Your public key XY values, your signature RS values, and your message hash, your prefix. Since it was signed on mainnet, that's why the prefix is this, and your original message that was signed.
Mhm.
So this confirms the whole, what do you say, your execution logic, verifying everything on Arbitrum, like verify fields on Arbitrum, verify message on Arbitrum, and bringing over the data to Ethereum. So you send this read, and then you have the data on Ethereum. So yeah, that's the whole execution logic for this project. Yeah.
That looks really awesome. Thank you. Thank you so much for walking us through all the steps.
Yeah.
Uh, I mean, I have like maybe one last question. Uh, what kind of applications do you feel can start using this now?
Yeah. So the main application that I see using this specific protocol would be something that works with your cross-chain swaps. So
Mhm.
in that sense, you can have one Ethereum and Mina mainnet wallet like linked together. You can, so how you sign into any protocol is you get a signature on Oro wallet or your MetaMask that says sign in this message to prove you have access to this wallet. So using the same message that you get on using like off-chain MetaMask or Oro, you can get that message. You can get the signature through that specific public key, and you can link to Ethereum wallet and your Mina wallet together. So in that sense, you can have your P2P swaps available. You have one Ethereum wallet that's sending, like, who wants to sell, let's say, $2,000 worth of ETH, and you have a counterpart on Mina protocol. So that way, if anyone what do you say, buys that $2,000 worth of Ethereum on Mina, you have that connection between two wallets. So we'll have what do you say, a group of two. One is Ethereum Mina, and the other one is also Ethereum Mina, and that way you can enable cross swaps over chains. So anytime anyone buys the Ethereum from here, he can send the Mina to this one. The main step would be to create that connection between two wallets. That's essentially the most important application I could see this work with.
So thank you. Well, Philip, you are the only one in the audience. So if you have any questions, please feel free, and I can read it out to him if you put them in the chat.
Thanks. Yeah. No, this was interesting. So just to recap, because this is the first time I've looked at your project, it's not about Schnorr signatures on Mina, but more about validating the Schnorr signatures on Mina on other ecosystems like Ethereum and Ethereum L2s, right?
Yeah. Yes. Yeah.
Oh, yeah. Interesting. Yeah. Thanks.
So I don't have any questions, Anuj. Thank you very much for coming on and sharing the project with us. And have a good one. Thank you, guys. Bye.
Thanks.
Bye all.